Hi, this week we learned about more in the lithography, especially the advanced technologies, which enables us to pattern into the nano size, more smaller. The first way that we learned was ARC, anti-reflection coatings. Um, as we can see in this name, it says anti-reflection, which is removing the reflection of the light. Because as we know, light is a wave. It affects the constructive interference, but also you have a destructive interference. With the difference of the wavelengths that we can use the destructive interference of the light and remove the reflection. The reason why we use ARC is if there is a reflection on the light, then there are more electrons that does the pattern, and it could affect the unexpected size of than what we expected. It could, if it's positive mask, then it could pattern a more thinner than what we expected. If it's negative mask, then it could make a more thicker than what we expected. So we use ARC. In ARC, there are two different types: top ARC process and the bottom ARC process. Top ARC is we put ARC on the top of the photoresistance, and bottom ARC we put it on the bottom of the photoresistance. And in the bottom ARC, we could divide into the organic by the materials, organic material, polymer, or inorganic. But we usually use bottom ARC and the inorganic materials because it has a very good effects of conformal deposition. It could deposit very uh, uniformly and good etch selectivity. That's why we use in organic bottom ARC. Another thing that we learned is PSM, phase shift mask. Like I said, light is a wave. If we shine the light, then it might make a constructive interference. Then if we wanted to make the photoresistance pattern like this, then because of the constructive interference, this what we expected cannot be shown. So we use 100 phase shift material in one of the slit of the slit to remove the constructive interference. So pattern could maybe look like this in one side and this in one side, making the destructive interference. So this is the way of the attitude phase shift mask, and one of the other way that we use is alternating phase shift mask, which is making a depth difference between the glasses. Another thing we learned was OPC, optical proximity correction. So if we focus in this picture, blue is the pattern that we wanted to make, but if we lithograph, usually the red comes out because at the corners it makes it round in the corners, and at the bottom it overflows and makes it more bigger than what we expected. So to make the pattern as what we wanted, like in the blue, we have at the beginning we have to make it as green as this we can see. Make it more thicker at the corners and make it more thinner into the overflow spots, so we can easily make the pattern that we wanted. This is the way that we do OPC. We can see right here the positions and the size of what we do in the patterns that what we wanted to make in the corners. We can see in these three parts are mostly what we wanted to make. Another way is off-axis illumination. Change. This is way that because we need more light phases to make the pattern that we want, we need more of the destructive orders. So if we have 3, and if we have 5 destructive order, then we could easily make more pattern, more of a size of a pattern that we want to make. This is the way that we do using the light wavelength of the light. If we can see this here, if we tilt the light, if the light was shining from the top, but if we tilt the light with the degree of alpha, then we can more bigger the size of the destructive order, the diffraction of the light. And this makes us with the off axis, if we tilt